All right, so today we're going to be talking about linear functions. And I know for a fact you've heard of that word linear before because we have discussed linear relationships. Now, linear functions, just like linear relationship, when you're looking at the graph, they have to be a straight line. Have to be a straight line. Now, linear functions is a function in which the graph of the solution forms a straight line. Therefore, the equation y equals mx plus b is a linear function. Remember, y equals mx plus b is our slope-intercept form. Our slope-intercept form. Remember, linear has to be a straight line. Linear has to be a straight line. So, when we look at a graph, that is any graph on a coordinate plane like this one. It might have a positive slope or a negative slope, or that might be a horizontal line. And remember, horizontal means it goes from left to right. Okay? Either parallel to the x-axis or is the x-axis. Now, when we talk about nonlinear, remember, there's one straight line that is not linear or that is nonlinear. That is your vertical line. Your vertical line is nonlinear because it's undefined. Great math curse word. And then we might have another graph that looks like a U, which we're going to talk about. That's going to be the thing we talk about later, which are called quadratic functions. Quadratic functions are not linear. They're nonlinear, or even trig functions, which are things that look like this. And I know I'm not drawing this great because I'm just doing it for time. This is called a trig function. You're going to talk about that in Algebra 1 or Algebra 2. Now, these things here, they're either linear or nonlinear, meaning they are a straight line except your vertical line, or they are not. So we're just going to talk about linear functions today. And in our first example, we're just going to graph a linear function. Now, remember that y equals mx plus b, where m is your slope. M represents that's where your slope is, your slope goes. And b is your y-intercept. And we need to remember that slope, y-intercept. Now we could use the slope and the y-intercept to graph a line, which we've done before, but we're going to use a table. We're going to use our first method, which is to make a table. We're going to make a functions table where you need an input, which is your x, and an output, which is your y. And your function or your equation goes right there in the middle. And then we have our order pair, our x and our y. Now, really and truly, you can pick any four numbers you would like, and that is fine. But here we want to keep numbers kind of low. And for that reason, we're going to pick the same numbers every time. I'm going to pick 0, 1, 2, and 3. So since this is your input, that means these numbers go in and a number comes out. So the first number we put in is 0, 0 plus 2. I replace x with 0, said x plus 2. Now I put 0 plus 2, which is 2. 0, comma 2. We have an ordered pantograph. And we know that this is the y-intercept because x is 0 and your y is some number. Here, that number is 2. So next input is 1. 1 plus 2 is 3. 1, comma 3. So 1 comma 3 is on that line with our wiring is at. Then we do 2 plus 2, which is 4, 2 comma 4. 3 plus 2, which is 5. 3 comma 5. Now, if you see a graph here, you can label your x and y axis differently, or you can label them all the same. I'm going to label them all by 2s, 2, 4, 6. My -1, there's right there, so this got to be -2. Then I'm going to go up. This is 2, 4, 6, because this 1, 2, 3, 4, 5, 6. -1, -2, -3. Now I could have easily did these by 4s and then these by 1s, but we don't need to since we're using 0, 1, 2, and 3. I'm gonna plot all my points here that I have. So 0 on X and then up to 2. This one says 1 and 3, so go to 1 and then up 3. Then the next, go to 0, go 2, and then 4, then up 4. Then the last is 3, 3 to the right, up 5. The last complete thing is to draw our line. And yes, you need to draw a line straight through and your arrow so they know that the line continues and is not an endpoint. Okay, let's try another one. We're going to graph the function y equals x minus 5. X is our input, y is our output. Our function is x minus 5. X, comma, y. We're going to use the numbers 0, 1, 2, and 3. So 0 minus 5 is going to be a -5. 0, comma, -5. 1 minus 5 is a -4. 1, comma, -4. 2 minus 5, -3. 2, comma, -3. 3 minus 5, which is -2. 3, comma, -2. And remember, these are negatives. So 3, can I take 5 from 3? No, I'm short by 2. So that's why that's a -2. Now again, I'm going to mark mine by 2. So 1 and then 2, 4, 6, and then 2, 4 here. And then we got -2, -4, -6. And remember, you do not have to number your numbers like I. You could have did them by 5s or 10s or 100s if you need to. It is up to you. But since we're using smaller numbers, this is the reason we are doing that. So 0 and then down to -5. 1 to -4. Our next one is 2 down to -3. And then finally 3, right? And -2. And we're going to, once again, draw a line because this is a function and we need to draw a line. Oh, and we're good. All right, so let's try to step it up a little because we were kind of doing a little easy ones. All these should be easy, but hey, we might still make a mistake. Next, we have the function y equals -2x. So again, I'm going to do my function. My input is x, output is y, -2x. And then we have x comma x comma y. Sorry, and my y looks like a 4. I apologize. So we'll do 0, 1, 2, and 3. -2 times 0 is 0. So this is 0, 0. It goes to the origin, which is a direct variation. We're going to go to our next video, and I'm going to pick it up here, right where we left off on C. We're going to pick it up here, right where we left off on C.